In this video, we are going to review a few examples of how to find the iteration of rational functions using the partial fraction techniques. When you see the rational functions, make sure that we follow the few simple steps before we can actually do the iterations. So first thing is you need to simplify. Make sure that the degree from the top is less than the degree from the bottom part. If not, then you have to use a long division. And then do the partial fractions. And at the end, we will do the integration. For example, we cannot use the substitution for this example, and therefore you are considering of using the partial fraction to find this integral. And we know that the degree on the top is 2, which is less than the degree from the bottom, which is 3. So we are good for that requirement. Now we can split this one into the integral of, well, the first thing is I should try to factor out the bottom part. So I can keep the top part to be the same. And I try to factor out the bottom x here. I see I have x to the third power and x to the first power. So I can pull out the x and I have x squared plus 4. Now after I rewrite this one in the factor form, then I'm now ready to split this one into the integral with the x and add to another fraction has the factor of x squared plus 4 and then dx. Because x here is x to the first power, so which is a linear, therefore on the top we should have a constant and let that to be a. This factor here is x squared plus 4. This is a quadratic or a second degree polynomial, therefore the one on the top should be the linear expression, 1 degree less than the bottom, or it has the form of bx plus c. Because this is the second degree polynomial or the quadratic expression, the top, the numerator, must be the linear expression, bx plus c. I already used a, so I should use another letter for b and a constant for c. Okay, so now what is the next step to help us to solve for the a, b, and c? So I know that I can rewrite 2x squared minus x plus 4 over x squared plus 4. I can rewrite this one as the sum of these two rational expressions, a plus bx plus c all over x squared plus 4. So the best way to simplify this expression is to multiply both sides by the LCD. And I know that the LCD is L, x multiply x squared plus 4. So we go ahead and we multiply x squared plus 4 on both sides. X squared plus 4. When I multiply that, this term and this term, they cancel out. And then I'm going to make the distribution here and here. On the left hand side, I only have 2x squared minus x plus 4. And when I make the distribution of this one to the numerator with a, the x and the x, they cancel out. So I have a x squared plus 4. And when I make this distribution to the second term, the x squared plus 4, they cancel out with the x squared plus 4. Therefore I have x and then bx plus c. And now I can simplify this one more term. Then I get 2x squared minus x plus 4 equal a x squared plus 4 and plus bx squared plus cx. We can actually simplify this further. I have a x squared plus 4a plus bx squared plus cx. And now we can combine the like term together. I see how I have x squared and x squared, so I can factor out the x squared. I have a plus b, and then multiply x squared for this term and this term. And then I have the linear term cx, and finally I have the constant term for a, and this is equal to the left hand side 2x squared minus x plus 4. Now, in order for the left and the right hand side to be equal so that the equations is balanced on both sides, number 2, the coefficient of the x squared term must be matching to the coefficient of the x squared term on the right hand side. So from here, I know that a plus b will be equal to 2. And then for the linear term, I have the constant c, and I have the minus 1 be in front of the x. So I know that c will be equal to minus 1. And then finally, I have the constant 4a and the 4. I know that 4a need to be equal to 4. And from here, I know that I can divide both sides by 4. A will be 1. So a will be 1. C will be minus 1. I have a. I can plug in a to be here, to be 1. So 1 plus b to be 2. And therefore, b, subtracting 1 on both sides, b will be 1. So I'm now able to solve for a, b, and c. I can rewrite this integral here and plug in the value of a, b, and c to here, here, and here. Then I should get the integral of a over x. So that should be 1 over x plus bx plus c. Bx plus c, b is 1, so 1 times x plus c. C is minus 1. So you can put the minus here. Minus 1 over x squared plus 4. And then take the integral with respect to dx. And then from here, I can further split the integral into 1 over x dx. And then I can add the integral of x over x squared plus 4. And then minus dx. And then minus the integral of 1 dx. 1 over x squared plus 4 dx. Okay, so I know that the integral of 1 over x right here is the ln of the absolute value of x. What about the integral of x over x squared plus 4? Well, this case, I'll let u to be x squared plus 4. Then du is 2x dx. Right, so I know that on the top, I have the x. So in order for me to get 2x dx, I need to multiply 2 on the top and then divide by 2. So I should have 1 over 2. And then I have du on the top and then over u. And that should be 1/2 ln of u, or 1/2 ln the absolute value of u, which is x squared plus 4. And finally, I know that this term right here, this is the inverse tangent. So this whole integral right here give me the inverse tangent minus 1/2 inverse tangent of x over 2. And then at the end, we add c. But I can rewrite everything here. So the first integral, I have ln of x. The second integral, I have this expression plus 1 over 2. Now you can chop the absolute value side. Why? Because x squared is already a positive number, and you add 4, you always get a positive number. So you can just chop off the absolute value side. And then minus 1/2 inverse tangent x over 2, and then don't forget to add c at the end. And that is the complete solution to this rational function. For the inverse tangent here, let's just recall the formula for the inverse tangent that you learned from calculus 1. So the integral of dx over x squared plus a squared, this will be equal to 1 over a and inverse tangent of x over a, and then add c. So I know that x squared, a squared, in this case we have number 4, so a squared should be 2 squared. 2 squared equals 4. Therefore a is number 2, and therefore I have 1 over a, which is 1 over 2, and then inverse tangent of x over a, which is x over 2, and the minus side I keep that in the front. So this is a formula for the inverse tangent.